Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Home Theater Geeks is provided by Cachefly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, recorded October 31st, 2011, episode 85, IPTV Update. This episode of Home Theater Geeks is brought to you by Ford, featuring voice-activated sync app link. Now you can control select smartphone apps with your voice, so you keep your hands on the wheel and your eyes on the road. Check it out in the 2012 Ford Fiesta and at ford.com/technology. And by Netflix. Watch thousands of TV episodes and movies on your PC, Mac, iPad, iPhone, or TV instantly. All streamed directly to you, saving you time, money, and hassle. For your free 30-day trial, go to netflix.com/twit. Hey there, Scott Wilkinson here, online editor of hometheater.com. This week's guest geek is Drew Major, the CTO of Echostar Advanced Technologies, which is currently working on IPTV, a hot topic these days. So I'm really happy to have Drew on the show. Hey, Drew, welcome.
Welcome. Thank you.
Those who are tuned into the live video stream at live.twit.tv or logged into the chat room at irc.twit.tv can post questions for Drew, and I'll pass along as many as I can as we go along here. So, Drew, I wanted to start with a little bit of your history. You actually were one of the founders of Novell, which is a well-known networking company, and you developed NetWare as an application to share files over local area networks. Have I got that right?
Yep, it's a long time ago. 30 years now.
Wow. And yet, sharing files over local area networks within a home or a building or something is now obviously very common practice. But sharing documents is one thing. Streaming media, particularly video, is quite another. Did you work on that in the early days, or were you just mostly concerned with getting a document from one place to another?
Well, the networks weren't even capable of doing that in those days. And so the big deal, you got to remember, we first shared a 10 megabyte hard drive.
I remember my first hard drive was like a 20 meg, and that seemed like a lot at the time.
Yeah, and so and that cost $2,000 or $3,000. So there made a lot of sense to put a network in, share the files, instead of using floppy drives, which was the alternative in the early days.
Otherwise known as SneakerNet.
Yep.
But today, of course, we have enough bandwidth on local area networks to, in fact, push audio and video around somebody's home. So the question for me always is, how do you assure what's called quality of service, or QoS, when transporting these video and audio streams around, so that they don't get broken up by somebody sending a file or checking email someplace else on the network? Is that something you work on?
Well, yeah, that's actually the fundamental challenge facing video delivery over the internet. If you back up or even in the home under any local area network, if you think about, the transition of, why networks work the way they do, one thing that was very fundamental early on was the design of delivery protocols that could deal with, everything goes in packets, but it could deal with lost packets. And so the invention of ways of dealing with that, the principal way that ended up happening was a protocol called TCP, which is, of course, used today, for all web, most traffic. And it's designed to deal in a elegant way, or at least a pragmatic way, to make sure that the data is fully delivered. But when they designed TCP, which, by the way, was designed by router vendors to make sure their routers didn't melt down originally. The guys, well, what it does is it makes sure the data gets delivered, but it imposes no guarantee about when it does get delivered. And so the reason,
which of course, that's not a problem with word processor files, but it is a problem with video files.
Yeah, well, it also means, even with a web, it tells you whether I can move my file in 5 seconds or 2 seconds. Depends on what's called packet loss and latency. Right. And those two factors happen. And of course, you got to remember the internet is amazing that it actually works, because you have a disparate set of literally millions of networks all combined together. And at every point where there's a router or a switch, even at a modem, there's a point where there can be a congestion point. And the way they originally designed the routers, and now is standard, there's an algorithm called random early discard, which basically throws, if there's a congestion point, if they're trying to put too much data down a particular pipe, the router just gives up very quickly and starts throwing away data. And then what happens is TCP realizes that and backs off and slows down. And of course, because of that, the internet works, which is great. But the problem with that is that it doesn't necessarily, you can't guarantee timeliness of delivery. And TCP guarantees delivery, but not timeliness of delivery. And so even within a house today, networks are fast, whatever. If you're running Wi-Fi, for example, when you set this thing up to me, you told me, hey, I can't use Wi-Fi to connect to Skype. Well, why? Because Wi-Fi typically is susceptible to errors and stuff, and you'll have a unacceptable level of packet loss that would in turn cause that our video conference here wouldn't work just because of packet loss. And so, even though networks are faster and better, the reality is in going wireless and when all your neighbors are streaming video, suddenly there's a switch point in Comcast or whoever you're using for broadband that overloads and data's dropped, TCP sessions go slower, video hiccups, and the internet works. But again, with video pays a price in terms of quality.
Rich C. in the chat room asks, how much buffering goes on to get these delivered packets?
It depends on what you're trying to do. Let me just describe what I invented. Give you maybe just a little more history. This is a geek show, so you can find.
Totally geeky. Get geeky on me.
Okay, so again, I tell you, so the internet throws away packets, TCP gets rid of it. People realized for many years, for 20 years, I got interested in delivering video or internet in mid-90s or even earlier. It was mid-90s because, made a lot of sense. But the problem is again, how to deal with this lost packet thing. That if there was congestion, some of the packets would be lost. How you dealt with it. And of course, with video, what they decided to do is you can decrease the quality of the video if there's congestion. Like, for example, if your pipe at home, your DSL connection is only 1.5 megabits, there's no way you can put a 2 megabit video stream to it. You have to figure out that you have to do less than 1.5 megabit because that's the size of that pipe. And so they came up with algorithms, and there was a protocol defined called RTP, RTSP that became a standard that basically it was a client-server protocol where the server would send data, would just start sending packets that had the video to the client. The client on the other side would occasionally reply back saying, oh, I'm losing stuff, I'm missing stuff. And then the server would look at that and it would say, I guess I can't send it at 2 megabits. I better back it off to 1.5 megabits. And so there would be kind of this interaction where it would be dynamically trying to push as much data through the internet as possible to the client, and then rely on the client to tell it, oh, I'm kind of in trouble, I better back off. Now, that's, again, was networking up through really, well, today probably half of the video streaming still uses that. Primarily, most of Adobe Flash. If you go to Hulu, it'll be using the RTP, RTSP implementation by Adobe. And a lot of other streaming still kind of does that. The problem with that way was, though, that that approach was that the server required intelligence on both sides, and the server was kind of blind. The client knew what was happening, and the server on the other end had to say, well, do I really believe that the client's in trouble? No, I guess he hasn't squawked enough yet, so I won't. But eventually, because with the networks, things can come out of order, they can be delayed, you don't know fully what you can believe because you're kind of at the other end of a pipe and someone's shouting at the other end, and it kind of just it's going through all these sections, and things all get distorted as it goes through the internet. So you don't fully know it because you don't want to overreact, but you don't want to underreact. So anyway, that was the standard way of doing it. Then the problem was that approach had two problems. One, that it was based on top of a layer actually below TCP called UDP that basically is not a guaranteed delivery thing. The problem with that was that it wouldn't go through firewalls, and people at home. So in the old days, if you use real networks, what would typically happen, there was an early pioneer of some of this video and audio streaming, in fact, for both of them. They would try to do it with UDP, and then if it didn't work, they'd back off and have to use TCP. And that, of course, meant that it took a while to start. And you want to watch video, and it's taking 15 seconds before it figures out what it can do and what it can't do. Because again, UDP was the firewalls and stuff over time that was one way hackers could, it's denial of service is like a UDP attack. And so there's all sorts of protections. And so basically that kind of killed or significantly limited RTP, RTSP. And so in the end, they put it on top of TCP, and they ran it through typically the HTTP socket, which is the web socket, which was for sure going to be open for everyone. But in the process,
I'm sorry. You said the HTTP socket?
Yeah, which is socket 80, which is all your web servers use that.
Right.
An HTTP socket. So you wouldn't have problems with the firewalls. But the problem at that point was you're on top of TCP, and TCP now has this other behavior of screwing up the timing of packet delivery. So anyway, that's kind of where the state of the art, and it wasn't really working that well in the past. And what happened was, because it was so complex and stuff, some people, and I think most famously by YouTube, they decided, well, hey, we don't need a special protocol to deliver video. Let's just make it as a big file. And we'll just use the normal file down transfer that's part of the web HTTP protocol. We'll just use that file transfer protocol. And then we'll do a thing called progressive download, which means we'll open the file, start reading so the video's on a file. We'll open the file, start reading the file. We'll see how fast it's coming, and if it's coming fast enough, we'll immediately start streaming and hope that the little progress bar never catches up to the display bar. And if that happens, then we'll just pause. Okay.
Right.
And we'll just use file transfer protocol. Forget these specialized video protocols; they don't really work. By the way, file transfer protocols are easy. And I could just use generic web infrastructure, existing web publishing infrastructure. I don't have to deploy a special file server or special video server for the Microsoft or the Real or the QuickTime or the Adobe. It's a lot simpler. I'll just use common web infrastructure. So That's what YouTube did. They were very successful. For small videos, it was fine. I don't know if you remember in the old days, quite often it would hiccup. Nowadays, it doesn't much because the internet gets faster and faster over time. So anyway, that was sort of the state of the art. And I had started a company wanting to do video distribution. I ought to put this on the record. I had a very interesting, now with Steve Jobs, I had a very interesting interaction with Steve back in 99 or 2000.
Oh, yeah?
I was trying, I'd met Steve because his next company, they wanted to sell it to Novell, and I kept meeting with him every year, and I couldn't figure out how to do it. And of course, it made more sense for him to go back to Apple, but he didn't really know what to do. So he kept meeting with me because he wanted to sell next. And again, I couldn't figure out how to make that work. And obviously, it only really worked when he went back to Apple. But
right.
Anyway, so I was in the middle of, I was trying to build content delivery networks for video delivery, realizing that you needed big HTTP web service and all sorts of stuff, and to make that, and video delivery would be the next big thing on the internet. And so the problem was, at the time, the pipes weren't big enough to do live streaming. So I thought, well, perhaps a model could be is people purchase a thing and then it downloads it, and then maybe an hour or two later they can watch the movie. Okay?
Well, that makes sort of more sense to me in many respects, because you don't know whether it's going to hiccup in the stream or whatever. But on the other hand, it poses the problem of copy protection. And if you're going to download something and store it locally, then you have it locally. And how are the studios going to address their paranoia?
And so anyway, that they had to do a lot of, you have to obviously do a lot of encryption to avoid that problem. And of course, a number of companies have showed up. Cinema Now, others, they showed up in 2003, 2004, et cetera. I was wanting to get started a little earlier. And so I thought, well, who's the guy who would get this really quick? And I thought, well, Steve Jobs would. And man, he owns Pixar. And, he's back at Apple, and, he would get it. So I arranged to go meet with him. And again, this was 99 or 2000. And at this meeting, and I proposed this idea to Steve. And I said, Steve, the internet's fast enough. We could start delivering video movies over the internet. What do you think about that idea? And Steve immediately said, that's a lousy idea. It's not going to work. And I said, because people want to watch videos immediately. They don't want to wait. And I said, well, Steve, I knew he was getting into being a father at the time. I said, Steve, when you rent a video from Blockbuster for your kids, do you go rent it and you can keep it for 5 days, you rent it, and a day or two later you watch it, right? And Steve came back and he said, nope, I go rent it and I immediately watch it. And I was with Phil Schiller, who's I think his marketing guy. He was the other guy in the meeting, and Phil rolled his eyes, okay, this is Steve, Okay, Steve, that's fine, whatever, and then, then we talked about it. It was actually a day of an earnings call. And of course, this is 2000 when Apple was just turning around. He was, he hadn't even done the iPod yet. I'm sure he was working on it at the time. So anyway, the discussion ended that Steve kind of didn't want to do a download. He wanted to he thought that you have to have it immediately, quickly. And so anyway, I had that discussion. Literally 3 years later, which I'll describe here in a minute, I invented a way to cheaply do immediate video streaming and kind of solve this problem. And I always wanted to have the discussion back with Steve, hey, Steve, you were right. People aren't going to wait. Guess what? I invented the way to do it over the internet immediately. And the ironic thing is, of course, what does Apple do today? Apple is the king of downloads and to wait. You download the patch, you download the thing, and then on the other hand, I was promoting that to him. He ends up commercializing it. And in the meantime, I invented what he had pushed me for. So
Talk about irony. Yeah, that's really something.
We're kind of king of both of those camps. And of course, anyway, let me explain now how I believe video is going to ultimately be delivered everywhere, and how that's going to change ultimately the way video is going to eventually get mostly over the internet, and it'll deal with issues in the house, deal with Wi-Fi issues, all these different issues.
And this is the invention that you came up with some 3 years after that meeting with Steve Jobs?
Yeah, it was 2003. I kept thinking that people would fix video streaming, and they weren't. And they had this RTP, RTSP, and then YouTube. This is prior to when they were acquired to Google. They were doing progressive download, and it was like, someone's got to figure out how to do it. And there's a simple way, and I've been thinking about it on and off for 10 years, but I didn't think was in a position to do it. And then one day I realized that I could do it, or that it needed to be solved, and I knew how to do it. And so I invented, it's really an evolution of what's called, which was called progressive download, the thing that like YouTube is using. But instead of dealing with video as a giant file, I said, well, let's chunk it into different chunks. Let's have 2-second chunks, and you deliver it together, and then have the client encoded at different bit rates. So, you can have a high, HD and a SD and a low bit rate, and, maybe do, half a dozen or even more bit rates. And
you mean encode the entire video file in multiple bit rates and have them all available?
Yeah, and then also chunk it into 2-second chunks.
Okay.
Key with doing the 2-second chunks was in that, and then access it via the web protocols, this HTTP protocol, and just have an intelligent client that basically says, okay, give me the next 2 seconds. It goes and gets it. Then it says, hey, did it take me 2 seconds to get this, or did it take me 1.5 seconds? Well, hey, if it only took me 1.5 seconds to get this 2-second chunk of video, maybe I can get a higher bit rate next time. So, and I go up on the bit rates, and I get a bigger file. And then things are happening. There's errors. The Wi-Fi is having problems. There's a bunch of your neighbors are downloading files, and suddenly you can't get the same bit rate you had before. And suddenly I ask for something, and it takes 3 seconds. Then I want to back off and say, oh, I better get a lower bit rate now because I'm in trouble. But the fact that we chunked the video and did it at multiple bit rates, and then had a client that was very intelligent, that could look and real-time monitor what was happening. And it was all done in the client. The server was actually just a dumb file server. It didn't have to, so it wasn't a client-server architecture other than the server just delivers the bits, but it had no intelligence around controlling or managing what was happening. And so you put all the intelligence in the client, use the common protocols, the protocols of the web, HTTP, you do it just for different bit rates. And so this is a variation or progression of progressive download, but now I get the best of both. And of course, when you come up with a good idea, it not only solves the problem you're solving, but you start solving a whole bunch of other things. It's like, this actually worked just as easy, just as good for video on demand as it did for live streaming. And for live streaming, I get time shifting for free. Wow.
How do you mean? You'd have to store this. You'd have to store them.
That's all you have to do.
Mm-hmm.
See, then basically, in fact, maybe even how you're doing this thing here, you'll do a live, and then you'll encode the VOD thing that's available afterwards.
That's right. That's exactly right.
Do it live or whatever. With our system, it's one and the same. There's no difference. It's really clean and simple and cheaper and everything. And it actually works well at higher qualities. So we built that 2003, actually filed for a patent in 2005. We ended up winning in 2005, 2006 to do all the video streaming VOD content for ABC, for Fox, for CW, for ESPN. We did the NFL.
So all these places are using this technology now, right?
Right, yeah. They are. And they were using it in the company that I founded called Move Networks and invented. That I invented this for.
But it does require an intelligent client. So the set-top box or whatever people have in their homes have to have this intelligence built in, right?
That's right. But the beauty of this approach is because it's using web, and the thing, and it makes, basically it enables the device that's streaming to go over an imperfect network and deals with it appropriately at the endpoint. So, it's easy to put it on a phone. It's easy to go wireless over, 3G. It's easy to go over Wi-Fi. Anything that has web, which is universal, as long as you install a client, you can stream to it, and it's no longer hard. The barriers aren't there in terms of deployability. Now, so let me just finish the story here.
Sure.
We showed Apple. Disney liked us a lot. Disney, they invested in us. They kept telling Apple that they had to support our protocol. So we go up to Apple. We started in, I think, 2007 to go up to Apple and kept telling them they need to support this. And they'd say they would, then they didn't, blah, blah, blah. And then much to our surprise, in 2009, Apple proposed a standard they called HLS, HTTP live streaming, that looked really close to what we'd done, and they did it as an IETF standard.
Was that a patent infringement?
Oh, yeah. We're not sure what we're going to do about that.
Okay.
Copied the same thing. So that's a separate thing. We didn't have the patent by then. So, but anyway, but the positive thing that Apple did there was propose it as a standard, and I view it as kind of a subset of what we've done. They because it was open, we probably should have done it sooner. We didn't. Unfortunately, we could have probably done the same thing. Anyway, so now there's a standard that's the adaptive rate standard that's out there with HLS. It looks actually pretty good, and quite frankly, we're going to start supporting it because it's kind of a setup we've done already, and I don't really want to fight that battle in terms of, because our negative was we had to get a client there, say.
Right.
Ended up having about 100 million, with it between ABC and Fox and stuff, we had about 100 million clients out there, but it was still hard. People accept they always give a pause when they have to install something new. So
right. And HLS doesn't require a client?
They do require a client still, but they're being embedded different places. For example, the only way to get on an iPhone or iPad is to use HLS. So, you notice, Jobs block Flash there, and certainly they haven't put Microsoft stuff. So basically, because of that move, and again, it's a subset, we can still do some of our secret sauce on top of HLS as much as on top of our own proprietary program. So we're transitioning to HLS. We publicly announced that going forward. Again, what we're going to do with the patent is a different thing. It sounds like you got to have patents anyway to be defense.
Yeah.
What it's doing with Android. Right.
Well, listen, we've got some questions in the chat room that I'd like to get to in just a moment. If you hold on just a second, I would like to take this opportunity to thank one of our sponsors for this show, which is Ford, featuring available voice-activated Sync App Link. Something new here from Ford. Sync App Link enables you to control select apps from your smartphone with simple voice commands while you keep your hands on the wheel and your eyes on the road. Very important there. You can do things like voice control Pandora in your car, listen to your tweets with OpenBeak just by asking with a simple voice command. Once your smartphone is linked to Pandora, for example, you can use voice commands to select your favorite station, make a new one, bookmark songs to purchase, give songs a thumbs up or thumbs down. Some of the voice commands include PlayStation Classic Rock, bookmark song, thumbs up or thumbs down. And with OpenBeak, for example, you can simply say, read timelines or read replies. Sync AppLink is built on an API platform that allows Ford to continue to work with developers in the app community to bring apps to life with voice in their vehicles. Voice-activated Sync AppLink is available in the 2012 Ford Fiesta. You can learn more about it and other technologies Ford is bringing to vehicles at ford.com/technology. So, Drew, we got some questions in the chat room or some comments here I just wanted to bring us up to speed a little bit on.
Okay.
Which is, let me just look for them here real quick. Does this give you equal quality on both ends, live versus stored media?
Yes, it does. Yes, it does. It can be done well. One thing that's nice about chunking video into 2-second chunks and encoding it that way is you can do a much more quality encode on the 2-second chunks in live. He adds a little delay, but not too much. You can do dual pass VBR encode on live, which we told some people. They said it's impossible. You can't do it. It's like, yeah,
we just did.
Yeah, approach it this way.
Yeah. Dark maybe. What software is this implemented in? What'd you write it in?
Most of it's C++.
Mm-hmm.
C++. Again, it's a client that the intelligence is in the client that installs, and it's just a plugin, basically a browser plugin.
Yeah. F-Loop asks, the Move player came and went. Is this protocol just implemented directly in Flash or Silverlight now? You mentioned Flash earlier.
Yeah, well, both. What happened is Microsoft, Apple, and Adobe all figured out that the adaptive bitrate approach using HTTP is superior to what they had done before. And so, Microsoft came up with this thing called Smooth Stream HD. I can't remember what Apple calls. Well, Apple calls theirs HLS. Flash calls theirs something else. I don't know what the name of it is. But basically, they're all evolving towards this, and a significant amount of streaming. Hulu isn't there yet, I don't think. But
what about Netflix? Dreamer77DD asks about Netflix.
Netflix definitely is adaptive rate. They started, we had a number of discussions with them. They ultimately decided to do their own implementation. I'd argue the one we did is a little better, but Flash is good. Netflix is good enough.
Right.
It's adaptive rate. It's definitely adaptive rate.
Let's see. Ans asks, couldn't you reverse engineer it for video upload like Skype? I'm not quite sure I understand the question. Do you?
Well, yeah. Adaptive rate works best on something where it's not totally real time. Skype here has to do something different because you don't want, if you're talking, you don't want more than a quarter of a second or whatever of delay between it. And an adaptive rate isn't suited for that. But for video delivery, even live, if you can accept 15, 20, 30 seconds delay off of live, and for scalability, Skype works great. Well, I guess, you guys are multicasting too. I'm not exactly sure how Skype does that part, but it's definitely oriented to the live, whereas adaptive rate does good on live that can be delayed just a little bit, and definitely for all quad.
You mentioned earlier about internet speeds in general increasing, and this was one of the questions I wanted to ask you because as far as I can tell, at least in the research I've done, in the United States, the per capita internet bandwidth available to homes is not very high compared to some places elsewhere in the world. I think it's well under 10 megabits, more like 7 or 8. So I wonder, this seems to me obviously to be one solution to that problem, which is getting high quality to the home. But with that kind of speed typically, and even less in many cases, the client would have to choose lower bit rates, and you wouldn't get the quality that you might want.
Well, the thing you have to remember is even if your last mile is high, these players everywhere, even throughout the world, they always oversubscribe it. Sometimes 20, 50, 100 to 1. So you've got a bunch of people that think they all have 10 megabits, and there's 100 people with 10 megabits, which should be 100,000 megabits, but the pipe that actually goes into the internet is only 30 megabits. So is everyone, and that being the challenge there when you're starting to talk about more and more video happening. The negative about video is you watch it a lot. With the web, you're in and out. You're doing stuff. You're bursting and quitting. But with video, particularly if you're starting to talk about doing a pay TV thing over the internet, you're talking it's on for 5-10 hours a day. And so what happens is even if it's the sum of the least parts, where there's going to be congestion points up the path that are going to really mess you up. Even if you've got tons of bandwidth in your home and tons of bandwidth from Comcast or from your fiber to the home or whatever.
Mm-hmm. Certainly on one of the recent shows that was just on rerun here before our show, Leo Laporte and John Dvorak were talking about, I think Leo mentioned something about how Netflix streaming accounts for 30% of all internet traffic. And when you count everything, it's far more than that. So we are certainly moving, it seems, towards a model where video is being delivered over the internet and using quite a bit of that resource.
And then you've got to recognize that if they're taking 30% of the internet and probably people are watching Netflix an hour or two a day, and only maybe 20% are Netflix subscribers or 30%, then you start seeing that there's going to be real problems scaling it farther to, hours a day and everyone else. Now, again, adaptive rate is very suited to deal with that issue, and there's a number of other techniques that can happen that could solve some of that. But definitely the issue does become, some of it ends up being business model.
Exactly. It's not technical, it's business.
You talk to telcos and they hate Netflix. And because Netflix does a couple of things. They take most of the bandwidth of their pipe, plus Netflix even publishes saying, hey, this telco's good and this telco's bad. And if you're having problems with Netflix, it's not my fault. It's you've got the wrong ISP, change ISPs.
No wonder they hate it.
Yeah, you don't like that because it's kind of a negative thing. So there's interesting business, what incents those people to, they have to sometimes have significant CapEx to upgrade their infrastructure.
Right.
Hundreds of millions of dollars, and Netflix, takes advantage of that in behalf of the user. Obviously, the user wants it, but the whole business model, and this is where net neutrality comes in. There's just a lot of interesting dynamics as to who can charge what, who can force what, and who can do what, and all that's sort of up in the air. Mm-hmm. I do believe adaptive rate's a better way of choosing it. I think that there's stuff beyond adaptive rate that we're working on that could solve this problem somewhat, but it definitely ends up being an economic problem of how to scale.
Right, and you are bumping up against the obvious limit of you have no control over the infrastructure, the bottom line infrastructure of bandwidth into individual homes. That depends on whether they put in copper or fiber optic or so on. Clearly, Verizon Fios has a lot more bandwidth available to it than most other systems.
But still, even upstream, they aggregate it way down, and The question is, and Akamai Netflix uses content distribution networks like Akamai, and they put proxy caches, HTTP proxy caches, that end up being replicators that fan out the content. So they get one copy into the server, send it out to 100 people. So it's a fan out point. Well, one thing that needs to happen is the telcos and the ISPs need to put those caches further into their network. That would solve some of the problem. But again, what's the business model that motivates them to do that? They're thinking about that, and I'm thinking a lot about it because that's kind of the scalability issue that still we're facing in terms of being able to video.
I wonder if the scalability issue might also apply to the data caps that most ISPs are now putting on their users.
Exactly the same thing, and how to get around that. And yeah, it's all kind of mixed up together. The reason they're doing data caps is because, if they don't do it, their business model doesn't work. They can't charge enough to the customer to pay for the infrastructure.
Yeah.
It has to work. It has to work.
The problem that I'm faced with always, I get back to, is I'm primarily concerned about quality. And so I wonder if IPTV can ever hope to compete quality-wise with broadcast cable satellite, which some would argue isn't necessarily that good, but probably generally speaking, it's better than currently delivered IPTV, not to mention Blu-ray.
Yeah, well, I happen to believe that we will get there.
Really?
Let me tell you why and how.
Please.
High level. Let me first of all explain one issue with adaptive rate delivery. The challenge that adaptive rate has is it's delivered. One way of describing it is unicast. It's a single stream to a single user. Okay. Whereas broadcast is multicast, where you have a single source, whether it's satellite, it's just being down from one satellite transponder, or certainly broadcast, it's from an antenna. If it's through the internet, it's still broadcast as a single stream and then fanned out. The problem with broadcast is, again, you can't time shift it. Everyone has to see everything at the same way. It's a traditional TV broadcast model, and more people want to do things on their own, and they want to push pause.
You do have DVRs, of course, now.
Yeah, that's kind of expensive, and it really only works on a set-top box. And now I want to have the same thing on my iPhone and iPad, and it's kind of complicated. So, but the fundamental problem, again, with the IP delivery of adaptive rate is that it is unicast. And so one solution is to put these proxy caches in the network close to the user, where, again, a single stream comes to that cache, it gets stored, and then it gets fanned out to dozens or hundreds of people there. And so in doing that, you replicate somewhat the characteristics of broadcast in terms of scalability, because that really ends up being the problem. If you can create a business model that incents the telcos to put caches there, potentially then you can caches you call it at the edge, which is close to the user. It's the place where the video will be originated. If you're in your home, you'll talk to that cache, and that cache, if the data isn't there, it'll get it from the internet. It'll make one copy, but it'll store it. And then if the second person asks for it, it won't have to go back to the internet anymore. It'll have it on its local hard drive.
Of course, that'll require the provider to install these caches, which is going to be some measure of capital expenditure.
Yeah, so you have to give them a business model to do that, and I think we're figuring out how to do that. But that, in a sense, will give you the scalability, but it also give you the best of both worlds in terms of on-demand, being able to watch everything, and that's kind of, quite frankly, the business model with Move now we're pursuing now that we've been acquired by Dish Network Echostar. you kind of think it's kind of funny. Why did Dish acquire an IPTV delivery company? But I, at the top, realized that the future is going to be more and more on IP delivery, and instead of watching that potentially start cannibalizing the Dish delivery system, which I don't think will take a while to have that happen. Instead, he wanted to say, well, let's bet on the future. And so that's why he purchased Move. And it's interesting working now for him because Dish obviously has a lot of clout and understands the TV delivery, and we're now building a next generation of that'll be IP based. And right now we are selling it to the telcos. And we were just at the telco TV thing, customers. But yeah, you need a business model that incents them to put that infrastructure in. And I would argue that Netflix doesn't have as strong of a business model there than potentially we would. Not that we're going to compete against Netflix. We want to empower telcos to do IPTV, similar to what Verizon's already done with technology. So
QWERTY in the chat room asks, how far out till we can select only the channels we want on DishNet? So in other words, a la carte systems rather than, packages.
I would love to have that happen. I'll tell you a couple of things that hold that back. The first thing is when you buy a subscription from cable, a pay TV subscription from Dish or DirecTV or Comcast or Verizon or whoever, it costs them somewhere at least $700 or $800 to fully provision that client. In the case of Dish, they have to go and put a satellite dish. They have to give you a receiver, and they have to do a truck roll. All that costs money. So if you look at it, and the average subscription is for 24 months, they try to lock in at least for 24 months. Well, why do they do that? Because it costs $700, and if you divide $700 by 24 months, it's like $12 to $15 a month just to pay back the capital expenditure they had to make for that equipment. So they have this huge burden they have to pay to even start breaking even, because they invested a lot to give you that dish and that receiver, and so that tends to make it so they want to sell you bigger packages because they have to recoup all this capital expenditure. Okay.
Yeah.
It could change that a little bit. Hopefully it would. The challenge there is the content guys also like to sell all their packages, and they've all figured out that the best way is to have big packages that are expensive, then everyone makes money. And if they break it up, perhaps they'll make less money.
Never a good thing.
About it, who wants to go do the deal? If you're at Disney or Fox or Turner, do the deal that 2 years ago, 2 years later, made it so that you were making 80% of what you used to make.
Right.
Wants to do that deal. Now, the challenge I think they're all worrying about is cord cutting. And they're worrying about, Netflix, man, instead of paying $70 a month for a cable, I can maybe Netflix is good enough for $10 a month. So it's a very interesting time with business models, and disruptive things are happening. And I think adapting and what we're doing here potentially can accelerate those things, certainly what Netflix is doing. Even with their recent challenges, their value is pretty high, but we're in the middle of transition. I would love to have the a la carte thing. I'm pushing for that. I think with over the top, the probability of that happening is going to be high, but it's definitely business model issues.
Yeah, well, certainly one of the companies in the middle of this transition is another of our sponsors for the show that I'd like very much to thank for their sponsorship. And that, of course, as you mentioned earlier, is Netflix, which streams thousands of TV episodes and movies directly to your PC or your TV, your Mac, even the iPad or iPhone. You can, and some Android phones for that matter. If you have a gaming console, you can stream from the Wii or the PS3, watching Netflix directly on your TV If you have a Roku box, same thing. You can get Netflix just about everywhere and from just about any device. And you can watch these TV shows and movies instantly without any hassle or returning discs or anything like that. You can even begin watching on one device and finish watching on a different device. Whichever way you choose to access Netflix, you can watch as many movies and TV shows as you want, and you can cancel any time. For Twit listeners, there is a free 30-day trial that you can get by going to netflix.com/twit. And be sure to use this URL when you sign up for that free trial, netflix.com/twit. And we thank Netflix for their support of the Twit Network, and we hope you enjoy watching instantly with Netflix. So, Drew, one of the things that I recently I've been thinking a lot about is the coming. Well, first of all, let me just say 3D has been a pretty big thing lately, and I was wondering if your adaptive bitrate system has any capability to do 3D streaming.
Yeah, all 3D is just you're sending more data, the two different sides of the thing. And again, our adaptive system, being so dynamic, can actually reliably deliver 3D better than others. You know, so it's much more flexible. It's just it's a software thing. It's not this big hardware upgrade. And so, yeah, I would think that eventually everything goes adaptive rate, and certainly 3D will be one thing that will go on it.
What about 4K? That was my other question. I've recently seen some demos of 4K that look awfully good, and to these people who all say, "Oh, physical media is dead," you know, everything's going to be streamed. I say, well, that may be, but are we going to really be able to get 4K streamed?
Again, it's the size of the bits and the pipes. You know, again, it ends up being business model. In my opinion, business model. If your ISP provider is given the right set of incentives to upgrade and to pay for all the capital expenditure he's got to do to make the pipes bigger for you, then all that'll happen. Certainly Verizon right now with fiber to the home is very capable of doing that. Mm-hmm. And what AT&T's done. And really DSL can move there. And quite frankly, the cable guys can as well. It's just a matter of the business model. Everyone has a big enough pipe at the last mile. The real question is the stuff packed back of that and all the costs associated with that, and what motivates them to be able. And again, our strategy in selling our product now through the telcos is to give them that revenue stream to motivate them to upgrade their broadband pipes.
I assume that you can accommodate any codec that we want to use, right? Have you heard of this new high efficiency video codec, HEVC?
I've talked to people who are building encoders, who are envisioning that they can do better jobs. Right now we're H.264.
Right.
All that progress, all that's good. That's kind of why I say ultimately the quality is going to reach the quality of broadcast, is because every barrier, and I think I've described a number of them here, and a lot of them are based. All those barriers are going to go away. It's going to compress a little bit better. The pipe's going to be bigger to your home. And again, adaptive rate gives you that flexibility. And I think the other thing that I would maybe want to finish with is just this thought that the beauty of adaptive rate ultimately is that it can tolerate errors in the delivery path. If you think about how traditional broadcast, cable, satellite, broadcast video has been delivered, it assumes that the entire delivery path has to be perfect. You can't lose anything. Mm-hmm. And so that, unfortunately, it adds a significant expense to put that high degree of reliability in the entire delivery path. Whereas adaptive rate, because the reliability is imposed at the TCP and at the higher level Everything below it can be significantly simpler and cheaper. And so ultimately, it's like, for example, even within broadcast systems today, they all use IP in their internal networks. They used to have all sorts of specialized networks, but the IP ended up being cheaper. What they have to do is super over provision it so that it never loses any data. But what's happening is the internet, the IP delivery paths, because it can be simpler, and because adaptive rate allows those paths, allows the internet to be a little flaky, allows the routers to throw away packets, allows Wi-Fi to temporarily lose some data when someone turns on the toaster in the middle of whatever spike interferes with the Wi-Fi temporarily, because at a high level, the resiliency is at the high level. The rest of the thing can be the delivery path can have problems. It can be simpler, and it doesn't matter. See, and so ultimately, then it's simplicity and price wins, and that's why I would predict long term that it'll all switch away from the old generation having to be perfect delivery paths to an IP based, which doesn't have to be perfect.
Well, this answers Webby's question in the chat room. Is streaming ever going to supplant over the air for real-time TV? And I think your answer is yes. Eventually and ultimately it will. Ultimately,
and again, it's a cost basis thing. That's the beauty of the IP, the internet, networking versus the older systems. And again, you're just starting to see that. Adaptive rate takes advantage of that. This is why I believe ultimately most video delivery is going to be adaptive rate. Certainly Netflix believes in it today. Microsoft, Adobe, Apple.
Yeah.
We know that's the future. It's just a matter of time, and it's a matter of business model, and and that's going to happen. I think the change on video delivery in the next 5 years is going to be tremendous. We're just getting a taste of it with Netflix and with streaming to our different devices. Ultimately, all the data that's, all the stuff that's on satellite and broadcast will be available. It's just inevitable.
Well, I have been a skeptic of that proposal in the past, but you are starting to turn me into a believer.
Will be in the pudding. I think that within the next year, you'll see some very interesting things.
Well, I'm certainly looking forward to it, and maybe in a year or so, you'll come back and share with us what you have done between now and then.
I would enjoy it too. That would be fun.
Great. Thank you so much, Drew Major, the CTO of Echostar Advanced Technologies. A fascinating conversation, and I do hope you'll come back and see us again. Thanks so much.
Thank you.
Okay. One more question, Drew. Sorry. You don't have any website or place where people can get more information. Is that correct?
Not really.
Not really. It's too advanced. Okay. So sorry about that, folks.
Yeah, there's some Move Network stuff that's kind of old, but that will be required by Echostar. So
right.
We don't have a newer version.
When you do have more information online, please let me know so that I can pass it along to my audience. And whatever I learn, you'll certainly read about at my online home, which is hometheater.com. You can also email me at scott@twit.tv, and you can follow me on Twitter at htgeekscott. Next week, my guest geek is scheduled to be me. I decided to do a chat room chat, so I will be simply here answering questions from the chat room. And something that I like to do once in a while, and it seems to get a good response from everybody out there. So get your questions ready. Anything home theater related is fair game, and just be ready to be in the chat room and post them, and I will be looking at as many and answering and talking about as many as I can. 2 weeks from now, my guest is going to be Eisuke Tsuyuzaki, the CTO of Panasonic North America. Big time guy. He's a very big wig in the consumer electronics industry, and I'm really looking forward to a conversation with him in 2 weeks. So be sure to join me for that, as well as for the Chatting with the Chat Room episode next week. Until then, geek out.